In the last video, we set up the constraints for this sales and operation planning problem and used Solver to minimize the overall total cost. And now what we need to do is look at some sensitivity analysis that can help us understand what are some of the major factors that are really driving the cost into this model. So we're going to consider two sensitivity factors. One is the demand. Of course, we're going to see it's very sensitive to the demand. And then another is the labor productivity. So what we've got here is the original model. My preference would be to go ahead and copy this tab by right-clicking on the tab name and doing Create a Copy. And then naming that tab, let's say Demand Sensitivity. All right, so what we can do is go up on this line for demand. What we're going to do is replace this demand by a 10% increase. So what we're going to do first is consider a case where demand increases by 10% and see how that would change our costs and how that would change our hiring plan. And so what we'll do is just, instead of the demand here being referenced from the forecast, we'll enter 1.1, which is an increase of 10%, and then multiply that by the demand that we find on the original, and the original is just named aggregate plan here. So we'll click on the demand for month 1 there. And so now that formula is over here on the demand sensitivity tab. So we'll copy that to the right. All right, so now what we need to do is we'll just use Solver. But let's set up the spreadsheet so that we can really see the difference here. So down here by the total cost, we're going to enter the original total cost and unit cost. And so I'm just going to click over, type an equal sign, and then click over to the original and click on total cost. And if we drag that down, we should get the unit cost. Now, these numbers here aren't correct yet until we use Solver, so we'll do that in a minute. And then we'll do the change. All right, so the change will be the new cost minus the original. And that would also work for the unit cost. And then we'll calculate the percent change. That will be helpful in a lot of cases. And that would be the change divided by the original value. And we can also calculate that for the unit cost. Now, this will just make it easy to see the changes in the sales and operations plan and how the costs are affected. So if we click Solver, we get here an interesting result when we try to use Solver. Solver says it can't find a feasible solution. And so what that means is one of the other constraints is preventing us from meeting demand if it increases by 10%. So we'll go ahead and click OK. And what we can do is potentially just have to look at some of the other factors that might be constraining this. For instance, here, in some of the months, month 1, for instance, we're using the maximum overtime hours of 500. But the one thing that's really noticeable here is that in a lot of these months, the workers hired is right up against the maximum hires per month. And remember, this solution here is not feasible. So what we're going to have to do is potentially see if there's a constraint that can change. So, for instance, what if we went ahead and considered a case where we could hire 12 per month? All right, would that be enough of an increase in potential hiring to allow us to meet this demand? And so if we click Solver, we see that it actually is. We get a solution. And so we see if we go down here that the costs basically have increased by 10%, a little more than 10%. Now, this is not a bad thing necessarily because we actually are earning more revenue because demand increased. And so this would really be kind of expected. What we also see is that the unit costs just increased slightly. So even though demand's increased, we're able to meet that if we can hire extra and produce these units at about the same unit cost. So that's just an example of how we might want to explore how the solution changes if we have increased demand. Now, other assumptions could have changed. We changed the maximum hires. Another big possibility would be if there was a way to get labor productivity into a situation where we're more productive, that would certainly also help. So we'll explore just a one-off change in labor productivity next. So let's go back to the original plan. And I'm going to right-click in that, and again, move or copy. And we'll name this labor productivity sensitivity. So let's suppose we can make a 10% improvement in labor productivity. And because labor productivity is units per hour, that would mean that we would increase the previous labor productivity by 10%. Now, operationally doing this would require probably some investment, maybe better machinery, better training, or something of that nature. So we'll multiply this by the labor productivity that's on the original plan. And then we'll just copy that over and make sure that copies over. So that would mean labor productivity would be about 0.473. Now we're going to again set this up here. We'll have the original cost, change, and the percent change. So we'll reference over to the original tab here. The cost. Copy that down to pick up the unit cost. So then the change would be the new minus the original. This hasn't changed, but it will when we actually use Solver again. And then the percent change would be the change divided by the original. So now we can go ahead and go to Solver and click Solve. And what we see is a really big change. If we can increase labor productivity by about 10%, we reduce our costs by about 7%. And so even if it took some investment, it's possible that that's worthwhile. And we'll explore that when we look at capital budgeting later on. Our unit cost has also gone down significantly by the same percentage. Now, one thing we notice here is that this will change the hiring plan. So in reality, this is going to require fewer workers hired. If we go to the original, for instance, in month 1, we had to hire 9.8 workers. If we can improve labor productivity, we only need to hire 5.26. And there will be other changes in the other months and likely changes to the overtime hours needed as well. So in the original, we use 390 overtime hours. In the new model, we use actually more overtime hours, but probably to make up for some of the workers we're not hiring. So it turns out the mix of the type of hours that we use can also be adjusted in each scenario to try to improve cost. So those are a couple of examples of sensitivity analysis that would be important in this case.